the product side also contains 12 number of hydrogen atoms, right? So it means hydrogen is also balanced now. Now let us come to oxygen atom again. The first reactant contains 6 into 2, that is 12 oxygen atoms. The second reactant contains 6 into 1, that is 6 oxygen atoms. So in total, LHS contains 12 plus 6, that is 18 oxygen atoms. Whereas RHS, 6 oxygen atoms are present in the first product and 2 in the second product. It means if I place 6 over here, then automatically number of oxygen atoms in the second product will be stoichiometric coefficient, that is 6 now, into the suffix of oxygen in this molecule, that is 2. So 6 into 2, that is 12, plus 6 in the first product, it makes 18. So now we have 6 carbon in LHS, we have 6 carbon in RHS, we have 12 plus 6, that is 18 oxygen atoms in LHS, and 6 plus 12, that is 18 oxygen atoms in RHS also. We have 12 hydrogen atoms in LHS, we have 12 hydrogen atoms in RHS also. Whereas glucose will also be in aqueous state and oxygen is dissolved in this glucose, it means it will be also in aqueous state. Correct? Now, what are the conditions required for this reaction? If you remember, plants require sunlight and chlorophyll to make this reaction occur and make their food. Correct? So it means now this is a complete balanced equation where we have balanced the number of atoms of each element in LHS and RHS also. We have mentioned the state, physical state of each reactant and each product also, and also we have mentioned the conditions required for this reaction to happen. Now let us talk about the third chemical equation, which is CH4 plus O2 gives CO2 plus H2O. Correct? Now, how many elements are there in LHS? Carbon, hydrogen and oxygen. And there should be the same elements in product side also. Carbon, oxygen, hydrogen, oxygen. It means carbon, oxygen and hydrogen. The same 3 elements. So, if you move from left hand side, the first element which we encounter with is carbon. Now let us try to balance carbon first in LHS and RHS also, the number of atoms of carbon, and then we will move to hydrogen and oxygen. Okay. Now on LHS you can see that carbon is present in only the first reactant. The stoichiometric coefficient, as nothing has been written ahead of CH4, means the stoichiometric coefficient of this molecule, this component, this reactant is 1. Nothing has been written as suffix of carbon, it means the suffix of carbon in this molecule is also 1. So number of carbon atoms present in LHS will be 1 into 1, that is 1. Correct? Now if you see the product side, carbon is present in the very first product. It means number of atoms of carbon can be calculated from first product itself. Nothing has been written as the stoichiometric coefficient of this molecule, this product. It means the coefficient of this product is 1. Nothing has been written as the suffix of carbon in this molecule. It means the suffix is also 1. So the number of carbon atoms will be 1 into 1, that is 1. So in LHS also we have 1 carbon atom, in RHS also we have 1 carbon atom. It means carbon is balanced already. Now let us talk about hydrogen, the second element in LHS and RHS also. If you see, the stoichiometric coefficient of CH4 is 1 since nothing has been written as the stoichiometric coefficient. Suffix of hydrogen in this molecule is 4. It means number of hydrogen atoms in this molecule will be 1 into 4, that is 4. Correct? Whereas the second reactant does not contain hydrogen, it means we can calculate the number of hydrogen atoms from first reactant itself, and it is coming out to be 1 into 4, that is 4. If you see the product side, the first product does not contain hydrogen, whereas the second product contains hydrogen. So if I have to calculate the number of hydrogen atoms in product side, I have to use the second product only. Now the suffix of hydrogen in this molecule is 2. Nothing has been done as the stoichiometric coefficient of this molecule. It means the stoichiometric coefficient of this molecule is basically 1. So number of hydrogen atoms becomes 1 into 2, that is 2. But we have 4 hydrogen atoms on the left hand side. It means if I place 2 over here as the stoichiometric coefficient of H2O, it means number of hydrogen atoms on right hand side will also become 2 into 2, that is 4. So hydrogen gets balanced. Now let us talk about the third element, that is oxygen. If you see, the first reactant does not contain oxygen, but the second reactant contains oxygen as it is oxygen molecule itself. The stoichiometric coefficient of oxygen here is 1 since nothing has been written. Suffix is 2, it means the number of oxygen atoms in this molecule will be 1 into 2, that is 2. So there are 2 number of oxygen atoms in LHS. If you see the right hand side, both the product contains oxygen atoms. The first product contains 1 into 2, that is 2 oxygen atom. Why? Because the stoichiometric coefficient of CO2 is 1 as nothing has been written, and suffix of oxygen is 2 in this molecule. So 1 into 2 becomes 2. So 2 oxygen atoms in the first product. Whereas if you see the second product, the number of oxygen atom will be 2 into 1, as 2 is the new stoichiometric coefficient of this product, and suffix of this oxygen atom in this molecule is 1 as nothing has been written. So 2 into 1 is 2. It means the number of oxygen atom on product side is basically 2 plus 2, that is 4, whereas we can see 2 oxygen atoms in left hand side. So if I place 2 over here, it means the number of oxygen atoms in LHS will now become 4. So we have 4 oxygen atoms on the left hand side also, 4 on the right hand side also. It makes our oxygen also balanced. Now carbon is balanced, 1 carbon on LHS, 1 carbon atom on RHS. Hydrogen is balanced, number of hydrogen atoms in LHS 4 and number of hydrogen atoms in RHS is also 4. Number of oxygen atoms in LHS is 4, number of oxygen atoms in RHS 2 plus 2 is also 4. So we have followed conservation of mass, we have balanced the chemical equation for balancing number of atoms of each element in LHS and RHS also. Now CH4 is basically a gas. This is the first member of alkane, that is methane, and it is in the form of a gas. Whereas oxygen, as we know, is also present in form of gas. Carbon dioxide is also a gas, whereas H2O will be in the form of a liquid. Now since this process is basically burning of methane gas, this reaction is basically burning of methane gas. Here on the right hand side, the water formed will be in form of gas. Why? Because of high temperature, this water formed will be in gaseous state. So finally we have a complete balanced equation where we are trying to balance this reaction, burning of methane gas, burning of alkane, the first member of alkane series, that is methane gas, where we have balanced the number of atoms of each element in LHS and RHS also. We have mentioned the state of each reactant and each product also. Now let us talk about the fourth example, fourth chemical equation, and try to balance this equation also with number of atoms of each element same in LHS and RHS also, and also mentioning the physical state of each reactant and product. Now on the left hand side we have only one reactant, that is ferrous sulfate FeSO4. On right hand side we have iron oxide Fe2O3, we have sulfur dioxide SO2, and we have sulfur trioxide SO3. Now LHS contain iron, sulfur and oxygen, 3 types of elements, correct? RHS contains iron, oxygen, sulfur, oxygen. It means iron, sulfur and oxygen itself. So now number of elements and are same in LHS and RHS also, and the elements are iron, sulfur and oxygen in LHS and RHS also. Now let us try to balance this chemical equation for following conservation of mass first, and then we will try to mention the physical states of each reactant and product, and also if condition required. Now iron sulfate the first element which we encounter with is iron. Since nothing has been written as the stoichiometric coefficient of this compound, it means the stoichiometric coefficient of this compound is 1. Since nothing has been written as the suffix of iron in this compound, it means the suffix of iron in this compound is also 1. So number of atoms of iron in this compound will be 1 into 1, that is 1. If we talk about right hand side, the only first product contains iron, whereas the second and third product does not contain iron. It means if we want to calculate the number of atoms of iron, we have to use the first product only. Now since nothing has been written as the stoichiometric coefficient of this particular product, it means stoichiometric coefficient of this compound is 1, and since 2 has been written as the suffix of iron in this compound, it means the suffix of iron is 2 in this compound. So number of atoms of iron in this compound will be 1 into 2, that is 2. But on LHS we have only one iron atom. So if I place 2 over here, then I have 2 iron atoms in LHS also, and I have 2 iron atoms in RHS also. So iron gets balanced. Now let us talk about sulfur. If you see this reactant, the only reactant present, the stoichiometric coefficient now of this compound is 2. Since nothing has been written as the suffix of sulfur, it means suffix of sulfur will be 1. So number of atoms of sulfur in this particular reactant will be 2 into 1, that is 2. Number of atoms of sulfur in LHS is 2. Whereas if we talk about RHS, you have 2 different products containing sulfur, SO2 and SO3. The first product does not contain sulfur, so for calculating atoms of sulfur, I will use the second and third product. Now since nothing has been written as the stoichiometric coefficient of SO2, and since nothing has been written as the stoichiometric coefficient of SO3, it means stoichiometric coefficient of both the products SO2 and SO3 are 1. Since nothing has been written as the suffix of sulfur in SO2, and since nothing has been written as the suffix of sulfur in SO3, it means the suffix of sulfur in both the product SO2 and SO3 are also 1. So number of atoms of sulfur in SO2 will be 1 into 1, that is 1. Number of atoms of sulfur in SO3 will be 1 into 1, that is also 1. So 1 plus 1, 2. So number of atoms of sulfur in RHS are 2, and already the number of atoms of sulfur in LHS is also 2. It means sulfur is already balanced. Now let us talk about the third element, that is oxygen. The stoichiometric coefficient of FeSO4, the reactant, in LHS is 2, and 4 as the suffix of oxygen in this particular reactant. It means the number of oxygen atoms in this particular reactant, or LHS rather, will be 2 into 4, that is 8. Now if you talk about RHS, all the 3 products contain oxygen. Now let us see how many oxygen atoms are there in RHS. The first product, if you see the first product, the stoichiometric coefficient of this product is 1, as nothing has been written there. Suffix of oxygen is 3 in this particular product. It means the number of oxygen atoms in the first product is 3. Since nothing is written as stoichiometric coefficient of SO2, it means 1 is the stoichiometric coefficient of SO2. 2 is the suffix of oxygen in this molecule. It means it contains 1 into 2, that is 2 oxygen atoms. Since nothing has been written as stoichiometric coefficient of SO3, it means the stoichiometric coefficient of SO3 is 1. 3 has been written as the suffix of oxygen. It means the number of atoms of oxygen in this particular product will be 1 into 3, that is 3. It means the first product contains 3 oxygen atoms, the second product contains 2 oxygen atoms, and the third product contains 3 oxygen atoms. So if we count these 3 numbers, if we add these 3 numbers, the number of oxygen atom in product side in RHS will become 3 plus 2 plus 3. It means 3 plus 2, 5, 5 plus 3, 8. So number of oxygen atom in RHS or product side are also 8, and number of oxygen atom in LHS is also 8. It means now we have balanced the number of atoms of each element in left hand side also and in right hand side also. So we have followed the conservation of mass. Now let us now write the physical state of each reactant and product. Ferrous sulfate is a solid compound, so we will mention the physical state of ferrous sulfate as S, which means solid. And iron oxide found will be also in solid form, that is the ore of iron oxide, it is in solid form. So I can mention S as the suffix of iron oxide, telling that it is present as solid form. Now sulfur dioxide and sulfur trioxide both are gases. So I can mention, or I can write gas as the G as the suffix of SO2 and also G as the suffix of SO3, telling that both are present in gaseous form. Now it means solid form of iron sulfate being converted into solid form of iron oxide and gaseous form of SO2 and SO3. But this requires some condition, that is heating of iron sulfate. So I have written heat above this arrow, which is a condition required. Finally, I have a complete balanced equation where I have balanced the number of atoms of each element in LHS and RHS, iron, sulfur and oxygen. I have mentioned the physical state of each reactant and product, iron sulfate as solid form, iron oxide as solid form, sulfur dioxide as gaseous form and sulfur trioxide also as gaseous form. And also I have mentioned the condition required, that is heating of iron sulfate will help the reaction to proceed further and form iron oxide, sulfur dioxide and sulfur trioxide. Now we have learned how to balance a chemical equation. We have seen how to balance, completely balance an equation, a reaction, by mentioning the physical states and conditions required also. Now we will try to learn about what are the different types of chemical reactions actually taking place.
Choose the right kindergarten, a right bag, and matching bottle to go with. The right school, the right friends. Choose the right subjects and score well. Be an expert in all. The right teacher, and make sure that they like you. Choose the right timing, the right bus, and take a cab if getting late. The right train, and don't stand near the gates. Mind the pockets. Better get into ladies' compartment. And make sure your mustache hasn't started coming. Choose the right study time and forget games. IPL, IHL, rock and metal, guitar, axe. The right group, and be a model to your brother. Seriously. Choose the right syllabus, the right test paper. Keep guessing questions for exams. Choose the right branch, the right college, the right stream. Choose the right career. Lucky to have a father's business to take care of and a father to allow that. The right counselor, the right form, and make sure the project is submitted on time. Choose the right website and rely on your friends for more information. Oblivious of the sites they have been to, there is no end to your woes. Getting better with every step you climb up the ladder. The summer vacations shorter, the bucket list bigger, the night darker, the books heavier. The only light you have is your friends ahead of you. Probably he is right. Ever thought how he got the direction? No more spending your energy and money on coaching classes. No more missing classes for rain, rally, and nonsense. Get your interest back in subjects through our creative ways of teaching. Doubts, concepts, applications, all explained through one vibrant animation. Subjects covered by multiple teachers with repeat telecasts. Special programs only for basic foundation and paper analysis. Personality development, career counseling, admissions, hobbies, all covered. A new approach to study with long-term perspective. So sit back comfortably in your homes and watch Study Spectrum TV channel.
Now let us talk about types of chemical reactions. reactions as the next topic in this particular chapter. Friends, when reaction takes place, nor do atoms disappear from the mixture, nor they appear from elsewhere. Atoms are shuffled, they are reorganized to form products. Correct? Now, in a chemical reaction, always remember that either bonds are broken or new bonds are formed. That is why these atoms of different elements reorganize to form products. Correct? Now, the first type of chemical reaction is combination reaction. Now, what is a combination reaction? A combination reaction means when two or more reactants combine to give a single product, then it is combination. As the word itself explains, combination, combining or combination of two or more reactants to produce one single product. For example, if I take calcium oxide, that is also called as quicklime. This is calcium oxide. If I dissolve calcium oxide or quicklime, which is the general name of calcium oxide, into water, then it forms calcium hydroxide, which is also called as slaked lime. Calcium hydroxide. Now, this is an example which tells us that when calcium oxide quicklime is dissolved in water, it means the two types of reactants are combining to give a single product. Correct? Now, I hope you might have seen whitewashing during your Diwali time or celebrations time. You whitewash your walls in your house. You might have seen that particular person who is going to whitewash the walls dissolves some white powder, that is actually calcium oxide, into a bucket containing water and forms a mixture, a thick paste type of compound, and he then whitewashes the walls of your house. But you might have noticed, after whitewashing the walls of your house or just after the whitewashing of your house, you might feel that the room has become a bit hot. Why? Because it also liberates some amount of heat. Now, anyways, if you see this reaction, two reactants are basically combining to give a single product, and that is why this reaction is called as a combination reaction, where two or more reactants combine to give a single product. This is an example where quicklime, also called as calcium oxide, the chemical name is calcium oxide, is dissolved in water to form calcium hydroxide and also liberates heat. If you mention the solid state here and liquid state here, then this will be your aqueous state. Correct? And if you see this equation, number of calcium atoms on left hand side is 1, number of calcium atoms on right hand side is also 1, number of oxygen atoms on left hand side 1 plus 1, that is 2, number of oxygen atoms on right hand side is also 2. This bracket, suffix of this bracket is 2, that is for both oxygen and hydrogen. It means the number of oxygen atoms on right hand side is also 2. The number of hydrogen atoms on LHS is 2. The number of hydrogen atoms on right hand side is also 2, as this 2, the suffix 2 is also for hydrogen, just because hydrogen is placed in the bracket. If you burn it in presence of oxygen, that should be obviously in gaseous form, it will liberate carbon dioxide, that should be always in gaseous form. Correct? So if you see this reaction, two different components, two different reactants, that is carbon, that is present in coal, and oxygen, that is a supporter of combustion, combine to form a particular type of gas, that is carbon dioxide, it means two reactants are combining to form a single product, and that is why this is an example of a combination reaction. Similarly, if we talk about formation of water, then we all know that hydrogen and oxygen are required to form water. So it means in this reaction, H2 in gaseous form combines with O2 in gaseous form to give H2O as water in liquid form. Correct? Now, here also if you see, two different reactants, two particular types of reactants are combining to give a single product. They are combining to form a single product. That is why it also falls under the combination reaction. But is this reaction balanced? Let us see if this reaction is balanced or not. Two hydrogen atoms on left hand side, two hydrogen atoms on right hand side, two oxygen atoms on left hand side, and one oxygen atom on right hand side. It means oxygen is not balanced. So if we try to balance this oxygen, I can place two over here so that oxygen atoms become two on the right hand side also, as oxygen atoms are two on LHS. But the problem is now there are four hydrogen atoms on RHS and two hydrogen atoms on LHS. So if I place two over here, then the number of hydrogen atoms on LHS also becomes 4 as it is on RHS. Now this reaction is a complete balance equation. Now let me tell you, this particular reaction, formation of water, is done under electrolysis process, where two different components, hydrogen and oxygen, are combining to form a single product. That is why it falls under the example of combination reaction. Now we all know that there are many reactions which liberate heat when being occurred. For example, just before this we have seen the example of calcium oxide quicklime being dissolved in water to form calcium hydroxide, and I have just explained that during whitewashing you can feel the heat, the room becomes hot as that particular compound, calcium hydroxide, is being coated on your walls of your house. Correct? It means there are reactions which require heat for being conducted. There are reactions which liberate heat when done. Those reactions which liberate heat along with the formation of products are called as exothermic reactions. Let us see some examples of exothermic reaction. For example, the first one, say burning of natural gas. Burning of natural gas. We have seen this reaction, this equation while balancing also. Natural gas is basically methane gas, the first member of alkane series, that is CH4. So if I am trying to burn this gas in presence of oxygen, it will form carbon dioxide and water plus heat. Now oxygen is also in the form of gas. Since this is a burning process, carbon dioxide will be in gaseous form, and also the water form will be in gaseous form. Since this is a burning process, huge amount of heat is being liberated, so obviously the water form will be in gaseous form. Correct? Now is this reaction balanced? Let us see. Carbon in LHS, number of carbon atoms are 1. In RHS it is also 1. Correct? If you see hydrogen, there are 4 hydrogen atoms in LHS which is contained in the first reactant, and there are only 2 hydrogen atoms contained in the second product in RHS. So I can place 2 over here to balance hydrogen atoms in RHS. Correct? Now if you talk about oxygen, there are 2 oxygen atoms contained in the first reactant only, not in the contained in the second reactant rather, not in the first reactant. So there are 2 oxygen atoms in LHS, 2 in the first product and 2 in the second product, means 4 oxygen atoms in RHS. So if I place 2 over here, then oxygen also gets balanced. Correct? Now this is a complete balanced equation which tells us that burning of natural gas is a basically exothermic reaction where it liberates heat along with the formation of products. Also, if we talk about respiration, we all know that during digestion we intake food and it is broken into simpler substances. Like for example, rice, potatoes and bread, they all contain carbohydrates, and carbohydrates during digestion are broken into glucose. This glucose in our body basically combines with the oxygen which we inhale to produce heat or energy, because of which we can do work. So if we try to write the example of respiration, then it is also an example of exothermic reaction. Respiration. How? This glucose C6H12O6 basically combines with oxygen to form carbon dioxide and water plus energy, because of which we can perform work in our day-to-day life. If we try to balance this equation, we have already seen this equation, chemical equation, earlier while taking the examples of balancing chemical equations. Here it was 6 and this will be 6. During the examples of balancing chemical equation, we have seen the reverse reaction where carbon dioxide and water was combining to form glucose and oxygen. Here it is breaking of glucose into carbon dioxide and water and also liberating energy, and this example is basically an exothermic reaction. Why? Because glucose combines with oxygen, or glucose reacts with oxygen, or glucose burns with the oxygen which we inhale during respiration to form carbon dioxide, water and energy, and this energy is responsible for us helping to doing work, different types of works. Also, if you decompose the waste, the vegetable waste, then that also liberates heat. That can be also considered as an example of exothermic reaction.